Most of us have probably seen or used a compass before. It's an ancient tool that helps us figure out which direction we're heading. You may also have seen a compass widget on a Garmin watch, a handheld device, or even on your smartphone. But what you might not know is that, using either GPS mode or a 3-axis electronic compass, what's the difference between them, and how do you use each one? Let's take a closer look. Whether you're out in the mountains or feeling a bit lost, you'll usually ask yourself 2 questions: where am I, and where am I going? A compass is one of the key tools that helps answer both. Before electronic devices became widespread, people relied on compasses, maps, and distant landmarks, using triangulation to estimate their position on a map. Today, with electronic devices and GPS, it only takes a few button presses to see your exact location on a map and even get precise coordinate data. That said, an electronic compass is still an essential tool for telling you which direction you're facing. Electronic devices can determine direction in 2 different ways. The first method uses GPS mode. It looks at the path you've traveled to determine your direction of movement. The second method uses a 3-axis electronic compass, allowing you to get direction even when you stop to find your way. Both methods provide direction, but each has its own limitations. Let's start with how GPS mode works. It's a bit like walking while dropping breadcrumbs behind you. Imagine a wild animal sees those breadcrumbs. It can tell which way you're heading based on the trail you just left. If an animal can do that, GPS mode can do it too. As long as you're moving fast enough, roughly about 1 to 1.5 meters per second, at that speed, GPS can more reliably determine which direction you're facing. If you're moving slowly or standing still, it becomes much harder to get an accurate heading from GPS. The second method, the 3-axis electronic compass, is also known as a magnetometer. You can think of it as a turbocharged version of a traditional compass. In addition to sensing the Earth's magnetic field to find north, it can also compensate for tilt. Why is tilt compensation important? Because everyone wears their device a little differently, which means the device is rarely perfectly level. A 3-axis compass compensates for that tilt as much as possible, so you can quickly and easily find your direction without having to hold your watch perfectly flat. The Oregon 300, released in 2008, used an older-style electronic compass. It required the device to be kept fairly level to get a reliable heading. Most modern devices now use 3-axis electronic compasses, which are much more convenient to use. Let's do a quick summary. GPS mode determines direction based on your movement path. You need to be moving fast enough for it to be accurate. The 3-axis electronic compass uses the Earth's magnetic field, and tilt compensation makes it easier to get a reliable heading. Now that we've covered how GPS and the 3-axis compass work, let's look at how to use them. Using the Garmin Forerunner 970 as an example, when you open the compass widget, you'll see 3 options: Auto, GPS, and Magnetometer. You can choose the one that best fits your needs. Auto means the watch switches between GPS mode and magnetometer mode. In other words, it alternates between GPS-based direction tracking and the electronic compass. GPS means the watch relies solely on GPS to determine direction. Magnetometer means the watch relies solely on the electronic compass to determine direction. Once set to auto, when you're running or cycling with a steady forward motion, the watch will use GPS mode to display your heading. When you slow down or stop to check your route, the watch will switch to the electronic compass to measure direction. One important reminder is that electronic compasses are sensitive to strong magnetic interference. This includes strong magnets or electromagnetic fields. When reading direction, try to avoid standing too close to vehicles, buildings, or objects like powerful fans that can affect magnetic fields. For divers who carry a magnetic dive pointer during a dive, try to keep it as far away from your dive computer as possible. This helps prevent interference with the compass. Also, while the electronic compass is calibrated at the factory and set to auto calibration by default, we still recommend manually calibrating the compass from time to time to ensure the most reliable readings. That wraps up our overview of how the electronic compass works. We hope this helps you enjoy your activities and get the most out of your Garmin device.